Okay, today we discussed about principal plane topic. I covered member under direct loading or axial loading. Today let me discuss about member under two mutually perpendicular stresses, sigma 1 and sigma 2. We can see sigma 1 parallel to sides BC and AD. Sigma 2 are perpendicular to sides AB and DC. This is about stress distribution. We can see two stresses, but resultant stress or force not in sigma 1 direction or in sigma 2 direction. It should be on the inclined plane FC. So we can find forces perpendicular to plane FC and parallel to plane FC. Force acting along plane FC is P1. Force acting perpendicular to plane FC is Pn. This is not P1. Yeah, you can tell PT. PT. Force along plane FC is PT. Force perpendicular to plane FC is Pn. Pn makes an angle theta with the horizontal axis. This is about PT and Pn. PT, this is Pn. PT is along plane FC. Pn is along plane normal to FC. Okay. So before finding PT and Pn, we can find force for sigma 1, force for sigma 2. We know stress means force by area. Force means stress into area. In order to find the P1, we need sigma 1 and section normal to sigma 1. Section normal to sigma 1 is BC. You know, this member has uniform thickness of A, or we can tell BC into 1. Height into thickness. This is a vertical member, so we can ignore horizontal dimension. We can consider height and thickness. Thickness is 1. This is lamina, unit thickness. So BC into 1 will be area normal to stress sigma 1 or cross sectional area of this member. So P1 is equal to sigma 1 into BC into 1. This is force P1. P1 is actually a horizontal force because sigma 1 is in the direction of axis. So P1 should be in the horizontal direction. Angle between Pn and horizontal axis is theta. So we can find here plane is inclined. So we can find components of P1 in the direction parallel to plane FC in the direction perpendicular to plane FC. Parallel to plane FC will be P1 sin theta. This is an angle. Angle between force P1 and component normal to plane FC is theta. So P1 cos theta will be in the direction perpendicular to plane FC. P1, this is cos theta means the other component should be in the direction parallel to FC. That value is P1 sin theta. P1 cos theta, P1 sin theta. Okay. This is about components of force P1. P1 cos theta, P1 sin theta. Next we can move to force P2. Force P2 is in the vertical direction, vertically downwards. Angle between force P2 and plane FC is theta. So here also we can find the components of force P2 based on the inclined section FC, that is parallel to FC and perpendicular to FC. Parallel to FC becomes P2 cos theta. Perpendicular to FC becomes P2 sin theta. Here we can see angle between vertical force and inclined section. So P2 cos theta is your horizontal component or force along section FC. P2 sin theta is force component in the direction perpendicular to plane FC. Okay. Now we understood the components of P1 and P2 based on plane FC. Here FC is an inclined plane. So forces on this inclined plane can be resolved into two, that is force component parallel to FC and perpendicular to FC. Normally we can say P1 is a tensile force. P2 is also tensile force. Both are acting away from the surface. So P1 is equal to stress into area. Area of face BC is BC into 1. Similarly, P2 is equal to stress on edge FB into area of FB. Stress on FB is sigma 2. Area is FB into 1. Okay, please listen. We can consider entire height because inclined section covers all the height, but inclined section considers only section FB. We can't say inclined plane between F and A. Between F and B only we can see inclined section. So instead of considering length AB, we can focus on FB where inclined section is located. Okay, very simple topic. P2 is equal to sigma 2 into, this is horizontal member, so we can consider horizontal length into thickness 1. Okay, now we resolved force components in the direction of FC, in the direction normal to FC. Then we derived forces P1, P2 in terms of stress and cross-sectional area. So first we can tell force component in the direction normal to FC is Pn. Pn is equal to component of P1 normal to section FC plus component of force P2 normal to section FC. Component of force normal to section FC is component of force normal to section FC is P1 cos theta. Component of force normal to section FC is P2 sin theta. P1 cos theta, P2 sin theta. P1 cos theta plus P2 sin theta. We know P1 value in terms of stress and cross-sectional area. P1 becomes sigma 1 into BC. P2 becomes sigma 2 into BF or FB. Okay. So now we written Pn in terms of stress and cross-sectional area and included angle. Next, we can try tangential force Pt, that can be total force also along the section FC. We can try Pt also in terms of P1 and P2. Pt is equal to P1 sin theta. This is force along section FC minus P2 cos theta. Okay. Force is a vector quantity. So Ft, tangential force from forces P1 and P2 along and perpendicular to plane FC. We can say Pt is equal to P1 sin theta. It is acting in the upward direction minus P2 cos theta. P2 cos theta acting in the downward direction. So minus P2 cos theta. Okay, next we can write it. P1 in terms of stress into area, sigma 1 into Bc. P2 is sigma 2 into Bf. Sigma 1 Bc sin theta minus sigma 2 Bf cos theta. So now we understood Pn part, Pt part. Here we can see sigma 1, sigma 2, its corresponding force components are P1 and P2 respectively. These P1 and P2 forces can be resolved into two with respect to plane FC. One is parallel to plane FC, another one is perpendicular to plane FC. Okay, next we need to find total normal force component, total tangential force in terms of P1 and P2. After writing P1 and P2, we can change it into stress into area. For P1 case, we can consider sigma 1 into BC. For sigma 2, we can consider, for P2, we can consider sigma 2 into section FB where this inclined section is located. Okay. After this, we can find normal stress across the section FC, that is equal to total force normal to the section FC divided by area of section FC. Pn by FC into 1. We can write sigma 1 term, cos theta term separately. We can put FC below BC by FC plus sigma 2 sin theta into BF by FC. From this triangle, this is right angle triangle, it is understood cos theta means BC by FC. Sin theta means FB by FC. So BC by FC can be written as cos theta. BF or FB by FC can be written as sin theta. Answer is sigma n is equal to sigma 1 cos square theta plus sigma 2 sin square theta. A cos square theta formula we know 1 plus cos 2 theta by 2. Sin square theta formula 1 minus cos 2 theta by 2. So we can simplify these terms. Sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 times cos 2 theta. We can write like this. This is sigma n equation. In terms of sigma 1, sigma 2. Initially, we need to find the components of P1 with respect to inclined section FC. After this, we can find the sigma n. That's it. Next, sigma t part. Sigma t means tangential stress or shear stress along section FC that can be obtained by total force along the section FC divided by area of section FC. So sigma t is equal to Pt by Fc into 1. Pt value is sigma 1 Bc sin theta minus sigma 2 Bf cos theta by Fc. We can write sigma 1 sin theta separately and Bc by Fc minus sigma 2 Bf by Fc into cos theta. Bc by Fc is cos theta, Bf by Fc is sin theta. Here sigma 1 times cos theta sin theta minus sigma 2 times cos theta sin theta. So we can keep common term out of this bracket. We can keep other terms inside this bracket. Sigma 1 minus sigma 2 times cos theta sin theta. Okay, cos theta sin theta, we know the equation. Sin 2 theta is equal to 2 sin theta cos theta. So we can multiply 2 on numerator and denominator. We can put 2 on the denominator along with sigma 1 minus sigma 2 and the other terms separately. Sigma 1 minus sigma 2 by 2 times 2 cos theta sin theta. 2 sin theta cos theta or 2 cos theta sin theta value is sin 2 theta. Sigma 1 minus sigma 2 by 2 sin 2 theta. Okay, next resultant stress. Sigma r is equal to square root of sigma n square plus sigma t square. This is the resultant stress equation. Okay, let me introduce another term, obliquity. Obliquity means angle made by the resultant stress with the normal of the oblique plane. Very simple. Sigma r is the direction of resultant stress that can be between sigma n and sigma t. Okay. So this is also right angle triangle. So sigma r is equal to square root of sigma n square plus sigma t square. From this triangle we can attain. We know parallel law, triangular law, superposition law. So we can easily tell. Obliquity means angle between resultant stress and with the normal stress. This obliquity tan value is equal to opposite side sigma t by sigma n. This is obliquity or angle between resultant stress and normal stress. Next, maximum shear stress. Maximum shear stress. We know shear stress equation. Sigma 1 minus sigma 2 by 2 sine 2 theta. When shear stress becomes maximum, sine 2 theta is equal to 1. So 2 theta is equal to 90 degree or 270 degree. Theta value will be half of this value, 45 or 135 degree. So we can draw like this, 45 degree, 135 degree. Angle between oblique section and vertical plane. So if you substitute sigma t is equal to sigma 1 minus sigma 2 by 2 sine 2 theta. Sine 2 theta value is 1. For getting principal plane, we can say shear stress is 0. Shear stress equation is we know shear stress equation. Total force along the section FC by area of section FC. We know normal stress equation. Total force normal to the section FC by area of section FC. For getting maximum shear stress, we can say equation 3.7. sigma t is equal to sigma 1 minus sigma 2 by 2 times sin 2 theta. For maximum shear stress condition, sin 2 theta value should be 1. Sin 2 theta is equal to 1 means theta value will be 45 degree or 135 degree. Okay, you can mute yourself. Within sin 2 theta is equal to 1. So 2 theta is equal to 90 degree or 270 degree. Theta value will be half of this value, 45 degree or 135 degree. Okay, this is the condition of maximum shear stress. Previously, I told in the previous case, sigma T max is sigma by 2. But here, sigma T max is equal to sigma 1 minus sigma 2 by 2. So, the two planes where we can see maximum shear stress will be placed at an angle of either 45 degree or 135 degree from the vertical member. Okay, next we can find the maximum normal stress. Normal stress value is sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta. This is normal stress equation. We know the condition of principal plane. In the principal plane, we can't see any shear stress. So sigma t equation should be 0. So sin 2 theta will be 0 or 180 degree. So theta is half of this value, 0 or 90 degree. In sigma n equation, we can substitute theta is 0 degree or 90 degree. If you substitute theta is 0 degree, you will get sigma n is equal to sigma 1. If you substitute theta is equal to 90 degree, you will get sigma n is equal to sigma 2. That's it. A very simple approach only. Okay, please listen.